Okay, so this is practicing finding the solutions for rational inequalities. Okay, so just like finding polynomial inequalities, you have to find the zeros, but you also have to find the asymptotes and plot them on your number line to find the solutions. Okay, so when we look at the numerator, we have zeros at 7 and -8, and the vertical asymptotes are at 5 and -4. So -8 is a 0. -4 is an asymptote. 5 is an asymptote. And 7 is a 0. So I label my zeros with zeros above them and my asymptotes with U's for undefined. Now we test our numbers, okay? So again, we're going to plug in values to find out if it's positive or negative, because our solutions, what we're looking for is where this rational function is less than 0, which are negative numbers. So when we plug in -9 into our factors, we get a negative times a negative, which is positive, and negative times a negative, which is positive. So here it's positive. Then I pick a number between -8 and -4, like -5, which is going to give me a negative and then a positive on top. So that's negative on top, but it's going to be negative on the bottom, which gives me negative here. Then if I pick, say, 0, from -4 to 5, I pick 0. I'm going to get negative, positive, negative, positive, which means it is positive here. 6, you're going to get negative here, and say I pick 8 here, this is going to be positive. So since I'm looking for where my function is less than 0, that's my negative values. So I put my x's where my solutions are going to be, on the negative values. Rewrite my zeros, bring my numbers down, put in my less than signs, and those are my solutions. So my rational function, my solutions are from -8 to -4, and from 5 to 7. Okay. Okay, so for this one, same thing, start with our zeros and our asymptotes. So I'm going to have an asymptote at -4. I have a 0 at 0. At 1 I have an asymptote. At 4 I have an asymptote. And at 6 I have a 0. So those are my 5. So I have 1, 2, 3, 4, 5 factors total. So 1, 2, 3, 4, 5 on my graph. Okay? And again, say we pick -5. I get negative, 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 negative. So this is negative here. -1. Get negative, 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 positive. So this is positive here. 1/2. So that's going to be positive, negative, 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 positive. So this is negative here. 2. Positive, negative, negative, positive, positive. So this is positive. 5. Positive, negative, positive, positive, positive. So it's negative here. And say 7. This is going to be positive. So now I'm looking for where my function is greater than 0. Those are my positive values. So I put my x's where my positive values are. Bring down my numbers, 0, 1, 4, and 6. Put in my less than symbols. And those are my solutions. From -4 to 0. From 1 to 4. And from 6 to infinity. Okay. So again, start with my zeros So I have zeros at 2, 0, negative 5, 0. My vertical asymptotes are at x equals negative 6. Now this one, if you plug it in, set it equal to 0, you move the 9 over, it makes it positive, divide by 3. That means x equals 3. Okay, so plot these. So at negative 6, I have an asymptote. At negative 5, I have a 0. At 2, I have a 0. And at 3, I have an asymptote. Now, on top, I've got negative times a negative times a negative. On the bottom, I'm going to have negative, negative. So plug in negative 7. So this is going to net negative, negative 5.5. So I get negative, negative, negative on top. On the bottom, I'm going to get negative and then positive. So this is positive. Plug in 0. You're going to get negative, negative, positive, negative, positive. So this is negative. Plug in 2.5. That's negative, positive, positive on top, and then negative, positive on the bottom. Excuse me, positive here. Plug in 4. I get negative, positive, 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 which is negative there. So I'm looking for where it's less than or equal to 0. Less than 0 are my negative numbers. So wherever I see a negative sign, I put my x. 3, 2, negative 5, negative 6, less than, less than, less than, less than. But now I have to include my zeros, only my zeros, which means I'm including my negative 5 and I'm including my 2. So my solutions are when x is less than negative 6, between 5 and 2, but including them, and when x is greater than 3. So remember, you only include your zeros. So our zeros are here and here. So we include those. We make those equal to, but not our asymptotes. And the last one, our zeros are at negative 1, positive 3. Our asymptotes are at 0, positive 1, and negative 5. So negative 5 is an asymptote. Negative 1 is 0. 0 is an asymptote. 1 is an asymptote. And 3 is a 0. So make sure I have 3 asymptotes because the denominator is 3, 2 zeros. They all match up. Do my sign chart. So plug in negative 6. So I'm going to get negative, negative on top, negative, negative, negative on bottom. So that leaves me with negative here, negative 4, negative, negative on top, negative, negative, positive on the bottom. So this is positive. So I got to use negative 1/2 here, which is going to be positive, negative on top, negative, negative, positive on bottom. So this is negative. Then I'm going to use positive 1/2 here, positive, negative, positive, negative, positive. So this is positive. 2, positive, negative, positive, positive, positive. So this is negative. And 4, positive, 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 positive. And since our solutions we're looking for greater than or equal to 0, we're looking for our positives. 3, 1, 0, negative 1, negative 5, less than, less than, less than, less than, less than, but equal to my zeros. So my 0 here, it's equal to, and my 0 here, it's equal to. So my solutions are from -5 to -1, but including -1. Then from 0 to 1, not including either. And then from 3 to infinity, including 3. And that's how you do rational inequalities.